Welcome to the Gauthmath class. Let's make math so easy.
Hello guys, I'm your teacher for this question. So this question is, write in a completely factored form relative to the integers. This is our expression. It's 6 times x cubic times y plus 12 times x squared y squared minus 15 times x times y cubic. First of all, let me remind you the distributive law. So the identity is a times b plus a times c equals to a times the sum of b and c. Well, for this kind of question, we're always trying to find the greatest common factor. And it's actually the common factor a here. So now let's get back to the original question. So here, firstly, let's rewrite the polynomial as 3xy times 2x squared plus 3xy times 4xy, and then minus 3xy times 5y squared. So now it's apparently seen that 3xy is the greatest common factor of these three terms. Therefore, we can rewrite the function in the form of a times the sum of b and c. So it's 3xy times 2x squared plus 4xy minus 5y squared. Now let's consider the polynomial with these three terms. Actually, it's in the form of a times x squared plus b times xy plus c times y squared, where the a is the coefficient of x squared, it's 2 here, and the b, the coefficient of x times y, it's 4, and the c, the coefficient of y squared, is -5. If we would like to factorize these three terms, we have to find any two value that the product equals to the value of AC, which is 2 times -5, it's -10 here, and then the sum should be equal to the value of B, which is 4 here. However, it's clearly that there are no such number whose product is -10 and the sum is 4. Therefore, the polynomial 2x squared plus 4xy minus 5y squared cannot be factorized further. Thus, 3xy times this term would be the final answer to this question. So overall, for this question, firstly, we have to know the distributive law, where AB plus AC equals to A times B plus C. And also, we have to find the greatest common factor of the polynomial, or the original expression. Then we can factorize the polynomial into the form of a times the sum of several terms. And then we have to test whether each bracket can be factorized further. If not, the completely factorized form is obtained. So that's all for this question, and thank you.